In this video, I want to discuss inequalities with regards to triangles. All right. The first thing I want to talk about is the triangle inequality theorem. What that says is that any side length of any triangle is less than the sum of the other two side lengths of that triangle. Okay, let me repeat that. Any side length is less than the sum of the other two. Okay, any side length is less than the sum of the other two. That's the triangle inequality theorem. Here's an example. Suppose that I had a triangle, and suppose that the sides were of length 3, 4, and 5. Let's see if it holds true for this one. Is 3 less than 4 plus 5? Is 4 less than 3 plus 5? Is 5 less than 3 plus 4? Okay, yes, of course. So that's using the triangle inequality theorem, or maybe I should say that the triangle inequality theorem guarantees that those inequalities will indeed be true. Okay? Now, if you understood what I just said, you can tell without trying to build triangles, you could tell if certain groups of side lengths even have a chance of making a triangle. Okay? I'm going to put here on the board 3 lengths in black. 4, 6, and 10, 8, 8, and 16, 6, 8, and 16. All right, so let's say I had these triplets of side lengths, these 4 triplets. Which one of those triplets of side lengths can correspond to a triangle, all right? So use the triangle inequality theorem to try to answer that question. And you might want to pause the video to try that for a second. All right, so I'm going to go ahead and explain now why the last triplet is the only one that has any hope of making a triangle. So the first one is out because 10 does not equal 6 plus 4. The second one is out because 10 is not less than 6 plus 4. The second one is out because 16 is not less than 8 plus 8. The third one is out because 16 is not less than 6 plus 8. Okay? Now, can I make the last triplet violate the triangle inequality theorem? Well, let's try. Okay? Is 10 less than 12 plus 14? Yes. Is 12 less than 10 plus 14? Yes. Is 14 less than 10 plus 12? Yes. So the last triplet, we could use those lengths to make a triangle. See how that works? All right. Now, I'm going to close this video by giving you one more result regarding inequalities and triangles. And I'll leave it to you as an exercise to prove this result. You can try to prove it yourself or look in the book or online to find a proof. And what the result that I want to share with you is that if you have a triangle, the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side. Okay, let me repeat that. The smallest angles and the smallest sides go together. The biggest angle and the biggest sides go together. Okay? So, for example, let's draw a real triangle with real angles and lengths and see if this is true. Okay, so here I have a triangle, and let's say I measured it, and I measured that this was a 90-degree angle, and this was a 30-degree angle, and this was a 60-degree angle, and let's say this had a side, one of the sides had a length 2, this one was length 1, All right, and then the other one, in this case, you would discover that it's equal to the square root of 3, or about approximately 1.7. Okay? All right, so the smallest angle is 30 degrees. Okay, so let's smallest angle, 30 degrees. What about the smallest side length? Maybe I should give names to the vertices, A, B, C. So the smallest side is side CB. Okay, is CB opposite the smallest angle? Yes, it is. All right. Now, what about the largest angle? The largest angle is 90 degrees. Okay, let's get, what's the largest side? The largest side is AB. Okay, is the largest side opposite the largest angle? All right, yes it is. So this is a very nice inequality, a very nice result that you can use when you're solving geometry problems. And so if you know, basically if you know that a certain angle is bigger than another angle, you know that a certain side length is bigger than another side length. And of course it also works with if you the smallest the smaller of two angles will tell you what's the smallest of two side lengths with regards to a triangle.